Okay, so this time we are doing two-step molar relationship problems. So it's kind of adding another step to what we did with the one step or single step, whatever. This is the video that I have a link for the first video. This is Tyler DeWitt's, and as I did yesterday or last time, I'm going to go ahead and have my version of how we would do this. So I'm going to kind of go back and forth between these two problems and the example on the worksheet that you have. So bear with me. But anyway, so let's start with this, the first problem. It says, what is the mass in grams of a single atom of oxygen? So what you have to do is first you have to figure out what your problem is. So you're given one atom of oxygen, okay? And you want however many grams of oxygen, all right? So the first thing you need to do is figure out on your circle, where are you starting, okay? You're starting over here in atoms and particles, and you want to be in grams, okay? So we have to go through two different types of calculations in order to get there. All right. So the first thing you're going to do is when you're moving from atoms is you go to moles. Well, you're going to divide by the number that you hit first. And then you're going to move to grams, and you're going to multiply by that number that you have there. So that's fairly simple, and it doesn't involve dimensional analysis. Anyway, so let's go ahead and look at it. So here, by the way, you need to have out your periodic table as well, because you're going to need that. So the first thing you do is you start out with one atom of oxygen, okay? So we have 1. You always write down your given number. Now, when we are going from atoms to molecules, we would go through 6.022 times 10 to the 23rd. That's the first number we touch when we're moving from atoms to moles, and then to grams. So we are going to divide by the first number that is in our path. So we would divide by 6.022 times 10 to the 23rd. Okay, now the second number that we come across, so now we are technically at moles. The second number that we would come across would be the molar mass. That's what we hit when we're coming through the crosswalk to go to grams. So molar mass is where we would get our handy dandy periodic table out, and we're talking about oxygen. In this case, it's just one atom of oxygen. So we would look here, and we can round to a whole number. Okay, so we're going to round to 16. Okay, and you would put all of that in the calculator, and you will end up with a number, and your calculator is going to give you 2.65, and it's going to give you a bunch of numbers depending on what type of calculator you're using. Bear with me, I'm trying to write through the phone screen, sorry. Anyway, so that's supposed to be a 23. Anyway, we have 2.65692, and then your calculator will show you an E most likely, and then that's a negative 23. So you would write the answer as 2.65692 times 10 to the negative 23rd. But, of course, we have to look at sig figs. So he gave us a single gram, or a single atom. So he gave us 1 sig fig. So what we would say, we would round that to 1 sig fig. It would be 3 times 10 to the negative 23 grams for one oxygen atom. Okay, and that's the first problem. Okay, depending on how he chose to interpret the one atom as how many digits, he might have come up with a different answer, but anything around that number is acceptable. Okay, so the next one I want to talk about is on your, because his example is actually kind of more in depth. So the next one I want to talk about is your the next problem I want to do is the one on the sheet that's attached to your lesson, I guess, for today. And it is the one that says 40 liters of nitrogen monoxide. Okay, so the problem says, let's say you want to find out how many actual molecules are present in a container of 40 liters of nitrogen monoxide gas. So that's our goal. So we look at what we're given. We write down the problem first, and we are told that we are given 40 liters of nitrogen monoxide. And then it asks us how many molecules are in that container. So we have to figure out how to get from liters all the way to atoms. In order to get through liters, we have to go to moles and then to atoms. So the first thing we're going to do is write down what we were given. We were given 40.0, and then we are going to divide by the first number that we come across before we get to moles, and that's 22.4. Okay, now the second number is what we're going to multiply by, and that's 6.022 times 10 to the 23. So 6.022 times 10 to the 23. Okay, and you're going to put that in your calculator, and it's actually going to come out to be 1.075357 times 10 to the 24th. And of course, we can't leave it like that. What do we have to take care of? That's right, sig figs. So we have 3 sig figs in our original, so we can only have 3 sig figs here. So our final answer is going to be 1.08 times 10 to the 24th. And we have to label it molecules of NO. Okay, that's our final answer there. Okay, now the last problem that I wanted to do with you was the one that he had. And the reason why I was waiting for this to be last was because it's more of a two-part type of problem. So it's going from one substance to a completely different substance. So it's asking what the mass of mercury has the same number of atoms as 62.4 grams of calcium. Sorry, my cat. Anyhow, so that the first thing we have to do is actually figure out how many atoms are in 64.2 grams. So this is, like I said, a two-part problem. So you have to do it twice. So the first thing we do is we set it up. What do we have? What do we want? 64.2 grams of calcium is what we were given, and we need to know the number of atoms. So, okay. Now, what you do to find that is, again, you look at where you're starting and where you want to be. So you're starting here at grams, and where we want to be is at molecules or atoms. Okay, so the first number that we come across is the molar mass, And the molar mass of calcium, sorry, technical difficulties. Calcium, you would round it to 40. So we would divide by 40 grams. Okay, and now we have to figure out how many atoms we have. So we're going to multiply by our 6.022 times 10 to the 23rd. And that's going to tell us how many atoms of calcium. All right, your calculator will give you that number. Okay, so since this is not technically the end of this particular problem, what we would do is we would leave that number and we would say, okay, so this is atoms, but instead of calcium, now we're looking at mercury, okay, because that's really what we wanted. But we wanted to know what the mass was of mercury, okay, so our problem is actually how many grams of mercury. Okay, so from there, what you would do is you would say, all right, well, I'm back at atoms again, still, rather. So I have this many atoms of mercury. So the first step I'm going to do is divide. So I've got 9.6653 times 10 to the 23rd divided by Avogadro's number, which is 6.022 times 10 to the 23rd. And again, this is the number that is between atoms and moles. It's Avogadro's number. I know I said it. It's just wanted to make sure we were clear. Okay, and then we need to multiply by the molar mass of what substance we're looking at. And this time we're looking at mercury. So we are going to go back to our periodic table and we're going to check out mercury, which is down here. Okay, and it rounds to 201 grams. Okay, so we would say 201 grams. Or 201, okay? And when you put this in your calculator, you end up with 322.605, and then, 322.605, okay? And now we actually have to look at sig figs. So, since we're looking at this being our final answer, we would say, okay, well, we started with how many sig figs in this original problem? We started with 3. So our final answer has to round to 3 sig figs. So 323 grams, and don't forget to label it, of mercury. Okay, so that's how you would do two-step equations, or I'm sorry, molar relationships. Again, the last one was a harder, more involved problem. The first two were pretty simple. So if you have any questions, let me know, and I would be happy to help you out.